Arizona Science is supported by Research Corporation for Science Advancement.
For Arizona Public Media, I'm Tim Swindle, Director of the University of Arizona Space Institute, and this is Arizona Science. Joining me today is Todd Lauer, an astronomer at the National Optical Infrared Astronomy Research Laboratory, or NOIRLab, in Tucson, who is using the New Horizons spacecraft to answer the question, how dark is space? Welcome, Todd.
Thank you. Glad to be here.
Todd, first let me ask, what does a spacecraft designed to study Pluto have to do with studying how dark is space and distant galaxies and things like that?
Well, Pluto is way out at the edge of the solar system, and we encountered it with New Horizons in 2015. Then we went deeper away from the sun into the Kuiper Belt and encountered Arrokoth in 2019. And that pretty much exhausted the list of objects that we're able to go by closely explore. So after that, we're just leaving the solar system. The sun is very dim, but we have an active, healthy spacecraft with a camera and a telescope in an environment that nobody's been in before. And it's extremely dark at the edge of the solar system. So it's actually the perfect instrument to ask this question.
And why is it darker there than it is around Earth?
Well, we got the sun next to us. We're sort of in the inner city, the bright city lights and everything else. And although it looks dark at night, you go out to the country, you can see all the stars. There's still a lot of dust in space around us, and it's lit up by the sun. And that makes it, harder to ask questions that require real extreme darkness, like understanding if the universe itself puts out some light.
There have been other spacecraft, the Voyagers and Pioneers 10 and 11, that have gotten to comparable distances. What's special about New Horizons?
The two Voyager spacecraft, which went, past Saturn, Jupiter, Uranus, and Neptune, turned off their cameras after they encountered their last planets. The Pioneer spacecraft actually didn't have what you would consider a real camera. They had to look over the whole sky, smearing it out and reconstructing it. And they did attempt to look at the distant universe with that, but they were still fairly close to the sun, and the difficulties of working with their data gave ambiguous conclusions.
The obvious answer to the question we started with of how dark space is pretty dark, but you're getting an answer more like not as dark as we thought, correct?
This has been a question that's been around for a while. It's a very natural thing to ask. How much light are you getting from the distant universe? And we know that there are galaxies everywhere. I mean, there's almost 1 trillion galaxies that we can potentially observe, like a blizzard, as it were, of galaxies, and they put out light. And the best bets were that if you add up all the light that these galaxies put out, well, that would be, how much light comes from the universe. It's stars, things that you know about. But you always want to make a direct measurement just to check your calculations, and looks like we're off by a factor of 2. We're twice as bright as you might have expected just from the galaxies.
Is this related to the cosmic background that we see as a result of the Big Bang?
Well, it's of the same flavor. The Big Bang was a theory for the universe, and it predicted that there would be leftover microwave radiation, as it were the heat from the Big Bang itself, but diluted over time as the universe expanded. And that was discovered in 1966. And that's why we believe that there's a Big Bang, and we've continued to look at this radiation. It encodes all sorts of information from the early universe, and we've learned an immense amount from it. But you ask, well, what else is there? Is there an X-ray background? Actually, there is, and we understand that. Is there an infrared background? Yes, there is. Ultraviolet, we don't know that so well. Is there an optical background is a natural question, and is the problem that I and the New Horizons team have been taking up.
What else is New Horizons doing?
Well, so New Horizons completed its primary mission now almost 8 years ago, which was to explore the Pluto system. It's drifting away, and eventually we'll lose contact with it. We think we can get to 100 times the distance from the Earth, maybe, that the spacecraft will hold together. We won't see it as far as we've seen the Voyager spacecraft, unfortunately.
Thanks for coming in and talking with us, Todd.
Thank you. This was a pleasure.
This is Tim Swindle, and you have been listening to Arizona Science. Our guest today has been Todd Lauer, an astronomer who is using the New Horizons spacecraft to study the background brightness of space. You can also listen to this and other Arizona Science segments by going to the Arizona Public Media website at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science.